Thank you. I'm really happy to be here, and I actually want to start with a small number of apologies. The first apology is I'm not wearing a jacket. This is not out of disrespect in any way. It's just very hot, and so I'm doing that. My second apology is that I am not an expert on education technology, so I learned a tremendous amount during this meeting. It's been really a wonderful meeting. And then my third apology is that I feel like I am standing between all of you and a good beer. And it's very awkward, so I will try to make it worthwhile. And one thing I can promise you, I will not go long because we have very important things coming up. One last thing before I start my talk. I thought the questions for Norm were fascinating. I certainly can't answer some of the ones that he could not answer about Korean education, but I did want to take a shot at, for example, the question about privacy, right? Privacy obviously is a huge concern having to do with AI, but we also need to remember that AI is not a tidal wave. It's not a force of nature. It's a tool that we use. And so if we have concerns about privacy, if we want to keep certain information private, all we need to do is create the appropriate policies, the rules, that will make that information private. It's not like AI is going to sneak around and break the rules and reveal this information. So I think that some of the concerns that we have about AI are really concerns about people and about society. And I'll talk more about that in a minute. Okay, so what am I going to talk about, especially given that I'm not an expert on education? As I've been listening to the talks, I realized that there's actually an elephant in the room, right? A big elephant. And that elephant is AI. We're talking about it, we've defined it, we're using it, we talk about what it can and can't do, but what exactly is AI? And so what I want to do in the 30 minutes or so that I have is do a little bit to put generative AI in particular, the latest flavor of it, I want to put it in context, and I want us to understand a little bit more about the technology. First point, which I already made but cannot be emphasized enough. AI is a tool. It's not a being. It's not going to come in and take over universities. It's not going to take over your life. It's something that you or somebody else is going to use, hopefully to make your life better, certainly potentially to make your life worse. It depends on whether it's being used by South Korea or North Korea, right? And I thought that Aaron's quote about Socrates and writing, which I never heard before, was so powerful because it shows that for thousands of years, as technology has come up, right, we don't think of writing as cutting-edge technology, right? But back in the day, right, when they invented pencils and letters and stuff, well, this is amazing. This is really, are we still going to have schools if we have pencils? Because what do you need teachers for if you have, so you see my point. We tend to, in some ways, overemphasize the nature of these things and underemphasize the fact that what we need to do, and of course a lot of people have been talking about this, we need to learn how to use these tools properly. The second point, which a lot of people have made, obviously there's some repetition as I'm coming last, is I think of AI as augmented intelligence, as a tool that we use to help us. But we can really be very imaginative about it. So Norm raised a great issue. He said, if you're curious and asking questions, GPT-4 is great for you, right? You're just typing stuff in, you're getting stuff back. But what about a person who's not curious, who doesn't know the right question to ask? The answer to me is very simple, right? There isn't just one style of teaching. So if we have models of teachers who successfully engage with those kinds of students, for example, by asking them questions. When I teach, I don't tend to wait for the students to ask questions. I ask them questions. How many of you, no, just kidding. But that is, I generally teach you. So that may be a way. So we should not think of AI as what we have today, but also as what's coming down the pike and what we can build that way. So it is still the case, right, despite the fact that I'm minimizing AI, that we are in a different age. And I think one of the things that illustrates that most dramatically is this chart, which shows for different products that most of us have used, like Google Translate, Uber, which I was delighted to find works in Seoul, Spotify, et cetera, all of them took a certain number of months to get to 100 million monthly active users. And it took ChatGPT 2 months, much less to get to that level. Recently, it's been announced that OpenAI is on track to have $1 billion a year in revenue. Okay, something obviously different is going on. That's why we're here. What I want to try to do in the next few slides is take what's happening, generative AI, and put it in a little bit more of context. So I like to say that our overnight success, quote unquote, right, this sudden appearance of ChatGPT has actually been 70 years in the making. That's roughly the age of the field of AI. And I've been working on AI for, gosh, almost that long. Maybe not quite, but a long time. So where the technology that we're talking about starts is actually back in 1958 when neural networks were invented. What's neural networks? It's simply a network where you have nodes, edges, connecting the nodes, and weights on the edges. And this is loosely inspired by the brain. We know now a lot about our brain. Our brain does not look like that, but it's loosely inspired by it. And the second point, which again is somewhat similar to our brain, is that these weights are tuned, they're changed by learning, by some process where you iteratively update these weights. What's really remarkable is that this very simple formalism, mechanism, whatever you want to call it, is incredibly powerful. Much more than we realized in the 50s, much more than we realized in the 80s, really only around 2012, which is just over a decade ago, did we start to see amazing success from this approach. So before we get to deep learning, I want to talk about supervised learning. And that is a term that's similar to big data, data mining, machine learning, classification, categorization. These are all synonyms for the same kind of narrow AI. And it requires three things. It requires human labeled data, I should say, often it's labeled by people. It requires some kind of target concept, and it could be very different. We could be learning to classify email messages as spam versus not spam. We could look at prices, airfares, and try to predict whether they're going up or they're going down. I started a company that was helping people figure out when's the right time to buy their airline ticket. It could be an image where we're trying to figure out, is there a tumor in this radiological image? So many different possibilities, but we have to specify that target. Again, the person does. And then the third point is when we shift from one target to the other, whether any of these examples, we have to rerun and recalibrate the program. It's not like that we have the Shazam program that Aaron talked about, which classifies music, and we say, oh great, let's take Shazam, but now let's use it to identify cancer. It's AI, right? That's not at all how it works. While there are some loose commonalities, there's a tremendous amount of work you have to do to go from a Shazam program to a cancer program. Actually, they're different programs, different data sets, huge differences. So this technology, while I'm describing its limitations, was also very powerful and drove progress in AI and trillions of dollars of value from 1980 to 2010. Now, the next thing that's happened, and again, the years jump around a little bit because in academia and in industry, right, there's some intersecting lines. But after 2010, specifically around 2018, people asked and answered two really, really interesting questions, which is what underlies generative AI and GPT and all that. And they're not particularly technical questions. The solutions are more technical. One question was, what if a machine could label its own data? So we would not need people to laboriously say, this is a positive example, this is a negative example, this is cancer, this is not cancer. And then even more amazing, what if we did not need to predefine the concepts, the targets? We didn't need to tell it, okay, now you're going to learn to classify rock music. Now you're going to learn to discriminate between cats and dogs, et cetera, et cetera, et cetera. What if it was general? And so generative AI was born based on these principles. And nobody's talked about what's inside the box, the black box, generative AI. And I want to just talk about it a little bit because at the level of abstraction that I'm going to talk about, it's actually really, really simple. There's a lot of details about how to make it run at massive scale and to understand what's going on. But here's the basic idea. You take, and I'm going to focus on text, although this is applicable to other items as well, but text is the easiest way to illustrate. You take a massive body of text, let's say all the sentences you can find on the internet. And then you take a learning program and you tell it, I want you to learn to predict the next word in the sentence. And if you think about it, it's easy in the sense that you have all these sentences and you're constantly looking, say, what's the next word? So you say the color of the sky is elephant. Okay, that's wrong, right? So that's a minus. You say the color of the sky is blue. Okay, that's right. So we've got a positive one. So what's really amazing here is that now we don't need to label the data. We just grab it off the internet as quickly as our machinery can. We put it into the language model and we learn. And again, the particular learning technology, be happy to talk to you about it, but it doesn't matter. It's some algorithm, right? There's always some algorithm. Two important notes here. The first one is that this really simple method is highly scalable, right? We've gotten rid of the human as part of the training program, and that's why it's we're able to run it over billions of sentences. Also, computers have gotten powerful enough, and the architecture supported scalability and blah, blah, blah. But bottom line is we removed the bottlenecks. The second important thing to remember is a principle in computer science that we call garbage in, garbage out. And what that means is that if you put bad things, garbage, into a computer program, bad things are going to come out. So if you read all of the internet, including all of the racism, all of the sexism, all of the xenophobia, all of the bad things, guess what? The model is going to learn those and is going to spit them out, right? So when we started building these models, we were very quickly embarrassed, terrified by the things it would say. And over time, we've gotten better at that. The second point is, while I talked about text, as you know, this is applicable not just to text, but also to images, also to software. There was an amazing statistic cited about how much AI-generated software there is on GitHub. But it goes way beyond that. So something that I haven't heard us talked about is digital biology. Biology is spitting an enormous amount of data. Gene data, protein data, et cetera, et cetera. Already we're starting to get huge results applying these types of models to biological data with, and starting to solve problems. So over the next decades, biology is going to be transformed tremendously. Okay, just the obligatory pictures. You've seen a lot of great pictures. These are some early ones. Here's a picture that you haven't seen. A lot of us who've worked in the field of AI have had what's called an AI moment. It's when we realize, wait a minute, I've been doing this for 40 years, 30 years, this is not the same. So there was a program called Lensa, is a kind of model, and you uploaded your photo, and it sent you back photos that tried to make you look cool. Now, this is as cool as I get to look. And by the way, I don't play guitar, I don't even play air guitar. I saw this picture, and I was like, wow, this is going to be huge. So just my personal AI moment. Look, there's tremendous challenges, okay? It's not like you hear about this and it's like, okay, 15 minutes or 3 years, we're going to be done. There's challenges of cost. It's extremely expensive in dollars to train these. It's expensive to run them. So you hear statistics about how much OpenAI has revenue of $1 billion. But how much did they spend to get that billion? Arguably, more. They might be losing money on every query. The cost is not just compute cost. There's a cost in energy. There's a cost in water. This is very expensive technology. My colleagues and I at the Allen Institute of AI defined a term called green AI, where we're working on how do you make this AI more friendly to the environment. And the good news is if there's anything the computer scientists are good at, is taking something that's really expensive and over time making it cheaper, a lot cheaper, right? And we've seen the history of that. So cost is a problem, but it's going down actually very rapidly. The second thing is tools. So tools for managing this are very primitive, and we're working on changing that. That will take some time. The third one, which was alluded to a few times, is hallucinations. Never trust an AI system, right? Whether you're a student or a professor. Here's an example from the Washington Post this year. ChatGPT, when asked, invented a sexual harassment scandal, named a real law professor, his real name, as the accused, and when asked for its references, pointed to an article in the Washington Post. Only problem is that article was made up. The AI system will not hesitate to lie, so you have to be very careful with that. Okay, with that, what is generative AI really good at? We're still learning this. And I had the privilege of being interviewed yesterday by a journalist, and at the end of the formal interview, he asked me kind of the funnest question. He said, hey, you're an expert on AI, I'm a journalist. Can you give me any tips for being a better journalist using AI? And I said, sure. I said to him, you're a writer, I'm a writer. What's the bane of existence of every writer? It's when the editor or the journal or the conference tells you, take this beautiful prose you wrote and make it 20% shorter to fit within the word limit, right? This kills us, the rewriting and so on. Well, generative AI, ChatGPT, whatever, does that without blinking, right? It writes something and you tell it, okay, rewrite that with a different word limit. It does that instantly. And then you tell it, yeah, but keep that wonderful example that you cut out. It'll do it again and again and again. So drafting, paraphrasing, summarizing is huge. As a journalist, I said to him, you are constantly having to learn new areas, right? You were talking to me about AI before, you were talking to somebody about something else. You can't read all the literature on this topic. Summarize it. When I was in college, and by the way, I was a student of Professor Koslin, who was one of my greatest professors, I focused on classes like his that I loved, and the computer classes, which took an enormous amount of time. And then I would come time to the finals, and it's like, oh, Japanese history. I haven't done any of the reading. I've been busy with other classes. I've got 6,000 pages. This is true. I still remember this, 40 years. I have 6,000 pages of reading to do in the next week before the final. If only I had ChatGPT. no problem. Hey, can you summarize Japanese history for me in 3.5 pages? Maybe a little bit more. I'll be ready for the exam. There's so much that this can do for you. Another question that people talk about is creativity. Can AI be creative? And I think that question is actually very confused, and it's because we don't have the right vocabulary to describe creativity, right? You say it's creative, it's not. But actually there are many aspects to creativity. You know, in the United States, we talk about kimchi. It's like, would you like some kimchi? Have kimchi. But there's just one word for it. All we know is this is kimchi, this isn't. I assume here in Korea, there's more nuances to kimchi. Same thing here. There's more nuances to creativity. So here's some of the creativity that AI is super good at. Mixing. If you're a good artist, painter, and I ask you to paint something, but do it in the style of Picasso, put in some Van Gogh, and maybe a little bit of Miro. That's extremely hard, right? Again, AI will do it with unblinking. Look, this, you know, it's already halfway right there in the picture. You tell it, this is one of the things I saw, which again completely blew my mind. You take some technical content, and you say, sure, you can explain to me this technical content, but it'd be more fun for me if you could do it in rhyme. If you can do it as a limerick, you know, things like that. And again, it says sure, and it'll do it. The third thing, and this is actually the most important one, and it goes with my statement, don't trust AI. To Norm's point, let it be an instructional aid as opposed to the actual teacher. And that is that it's good as an assistant, as an aid, as a co-pilot. You don't want it to be in charge. One of the most fundamental principles for AI, as I mentioned, right, it's a tool, is people should remain in charge. So there was this question, are we going to have universities, or are we going to have schools and so on? It's entirely up to us. We're in charge. AI does not make the decisions, we do. The things that we can see is the potential for making the systems that we have a lot better. So I can't remember the last time I've stepped into a physical library. But all the universities I know have huge physical libraries, right, that are expensive and, you know, either empty or people go there to, I don't know, hang out. As I understand, the University of the Future doesn't have a physical library, right? Because you don't need it. You want to have coffee, go to a coffee place. You want to date, well, you do that online too, at least to begin with. But we don't need physical libraries. So there are huge potential for optimization using AI. So where does it fall short? I mentioned it's not reliable, it's not consistent, it's opaque in the sense that you don't really know what's going on inside, even despite my explanation. One of the things to be very careful of, there was mention of explanations. And of course, explanations are important and they can be very useful, as you were saying, right? They can be useful in helping you understand why you got that hint as a student. But the thing you have to be very careful of is it's not genuine. And the best way to see that is if an AI system tells you something and you say, explain yourself, it will produce an explanation. And then right then and there you tell it, okay, explain yourself again in a different way. And it'll give you a completely different, inconsistent explanation, right? It's not really the explanation, it's kind of trying to figure out what to say to satisfy you. Another limitation of the current version of AI is that it's one size fits all, which of course is not good for education, not good for personalization. So if we ask ChatGPT a question, we can play with the prompt some, but initially it kind of answers you in this officious tone, it's always defining its terms, it's kind of annoying and boring, right? Over time, we can have variants of that model that are a different variant for each individual. It could be a different variant for each individual on a different day. These variations on large language models are tremendously powerful, right? That's what could help it teach us better. That's what could help it speak in our voice when we need to, and so on. Two much harder problems that, again, are solvable in the long term, but are really very, very hard is, one is judgment and taste, right? So, like I said, it'll produce pictures, right? You tell it cats in outer space, it'll produce 10,000 pictures of cats in outer space. You tell it in the style of Picasso, et cetera, et cetera. But which of these pictures is good, is aesthetically pleasing, is emotionally moving? That it's going to have a very hard time with. So Pablo Picasso once said, computers are useless. They just answer questions. And the same thing is true here. AI, as it stands, is useless. It just answers our questions. Okay, that's not completely useless. Obviously, it has its uses. But it doesn't know what are the right questions to ask. It doesn't know how to employ judgment, how to have taste. That is a very hard problem. The second thing is, despite its amazing abilities, it's quite a lot better in the small. So if you want an AI system to help you write, let's say, a book, you can't just ask it, hey, write this book for me. It'll be an absolute garbage. You can't even ask it, write this complex computer program for me. Again, it's going to be garbage. It's much better in the small. You tell it, write me a paragraph on this, or draft me a paragraph on this. It'll do great at that. You can tell it, okay, I have this little function that I need to write or fix, or I have a little test that I need to do in my code. It'll do that. It's really good in the small, and it still fails completely in the large. I like to point out to people that GPT-4, however wonderful it is, did not write GPT-4, right? People did. And furthermore, when we look to the future, because this technology is moving rapidly, GPT-5 is not going to write GPT-6, right? It's still a limited tool. It's still good in the small. It does not see the big picture the way that people do. And that's very important to remember. Okay, so as you can tell, I'm excited about the technology. I'm an optimist. But I do want to remind you that beyond education, right, and we talked about kids cheating and other challenges, there are many other challenges having to do with AI. One challenge is jobs, although again, it's a very complicated one, right, because computers do tasks, they don't do jobs. We have a negative birth rate here and in other advanced societies. I was on a panel recently with Rod Brooks, who's a very famous roboticist, and he said, and he's kind of likes to get the audience going, he said, I'm not worried about not enough jobs. I'm worried that we won't have enough robots to do all the things that we need to get done. So, and interesting, he didn't explain why there would be a shortage of robots. I don't know, maybe supply chain issues or whatever. But it's a way to get us to think about the fact that there are a lot of jobs that are better done by machines. For example, during the pandemic, a lot of doctors and nurses died, right? If we had the right robotic systems in place, we could have saved those lives. And a lot of people, a lot of patients didn't get as good care as they could have if we didn't have those robotic systems. Anyway, you see, I talk about the negative, but I can't help but switch to the positive. I mentioned bias and toxicity, right? These models will spit out horrible things. I do believe that's an eminently solvable problem. A huge, huge problem that is happening right now and is actually, I think, going to get worse in the next 12 months is misinformation. We've had misinformation for a long time. It's gotten worse in the 2020 elections in the United States. But generative AI makes it a a lot worse. And the reason is the same way that the printing press made the dissemination of information, made the cost of that go down, and then of course software made it go to zero, right? So I can have a document and I can share it with 1 million people or 1 billion people essentially for free. The cost of generating information is going down to zero as well. So what does that mean? Well, for example, I talk to people on YouTube and I say, how prepared are you for misinformation? Deep fake videos, right, that tell us things that are completely untrue. And they say, oh, we're ready. You give us that video, we'll identify it, we'll shut it down before you know it. We're all set. I said, that's great. What if there's 20,000 videos, each of which is completely different? They were generated by AI to achieve the same effect. Actually, they're tailored to influence different constituencies, to get them to retweet it and so on. They're very different, except that they're all driving to the same outcome, which is influencing the elections or creating a panic in the stock market. And the person at YouTube said to me, look, a bird. And when I looked, he ran away. My point being, that did not actually happen. My point being is that, that's a terrifying prospect that we don't have an answer for. I saw today that the head of the Securities Exchange Commission in the United States, the SEC, was testifying that in the next 10 years, he anticipates if we don't do something, there will be a huge market crash caused by generative AI, and we need to address it. We don't have the tools today. He was asking for us to build those tools. So huge problems. I also want to mention, shifting to the positive, some of the really exciting things. So obviously, we can think about things that we're doing today and how we can do them better using AI. But one of the most exciting things is thinking about things that have never been done before and using AI to do that. So for example, and again, I don't mean to make it magical and mystical. It can be as mystical as you like. But simply the idea that was mentioned, that you get your feedback instantly on your work, automatic grading, that you get that feedback even as you're working, in the classroom, outside the classroom, all that. That's not something we could even conceive of, right? You can't have a class of 30 kids and have a tutor for each kid 24/7 whenever they feel like doing their homework, which is certainly not when I tell them to, right? We all know that. So it's 2 o'clock in the morning, finally my son decides he wants to do his homework, but he needs a tutor. Good luck with that. Well, with AI, tutors are standing by. And you know what? You don't like that tutor? I've got a different one with a different attitude. This tutor's funnier. You see what I'm saying? We can conceive of some amazing things. There are tremendous opportunities. And I also want to mention that often when you see a challenge, the other side of it is an opportunity. So one really interesting example was, for a while, this was a few months ago, the most popular song on Spotify was a fake song generated by AI in the style of the musician Drake. And his company, right, as a violation of his copyright, insisted that Spotify take it down. Grimes, a different musician, said, no, I want to do something different. Use my voice, but let's just split the proceeds 50-50, right? Generate new songs by me that I haven't had time or the idea to, but let's just share the revenue. Seems a lot fairer, a lot more exciting. So there's the problem of forgery, but there's the potential for creativity. We talked about job loss, of course, but let's talk about productivity gains. Again, outside Korea, let's just talk about the US. Productivity has stagnated for decades with tremendous implications for society, for people's well-being, right? How much money they make. And again, we have huge problems with social inequality in the US and in other countries. We can argue about how to better divide the existing pie, the money that we make, and we should argue about that. But the solution is always to grow the pie. And an increase of 1% per year in productivity could do tremendous to solve the economic problems for many people. So AI represents that potential, the potential to have an unprecedented increase in productivity. So with that, I want to leave time for questions. I'm going to end by just reiterating 3 points. One is, yes, this is disruptive technology, as we've seen, as we've feared, as we've hoped. The choice of how it's used is ours. If there's anything you take away from this talk, is don't let anybody tell you, oh, this is how it's going to be with AI in education, in this context. You tell them, right? You're in charge. People are in charge. This is a democracy. You tell them how it should be. It's our choice. The second thing is, if you want a one-line shorthand of, so how good is this generative AI thing? My favorite line, and this is from Peter Lee from Microsoft, he says, generative AI is both smarter than you and dumber than you. That's how it is today. That's how it's going to be for a long time. And then lastly, going to another question that the reporter asked me, he said, so if AI was a movie, generative AI in particular, where would we be in this movie? Are we in the middle, at the end? Are we in the beginning? And what I said to him is, we just finished watching the trailer. The movie hasn't yet even started. Thank you very much.
자, 슬라이도에 올라온 질문 몇 가지 진행해 보도록 하겠습니다. We choose several questions. So, could you answer the first question on the screen?
Sure. In the use of generative AI, how well the prompts are utilized becomes a criterion for obtaining good/desired results. Very true. Consequently, there's a possibility the meticulously crafted prompts by prompt engineers will be shared, leading to situations where identical results are obtained. What approaches can be taken in educational methods to integrate generative AI while allowing individuals to express their own creativity? Wow. What a great question. That's usually when a professor asks a question, doesn't know the answer. So it's, oh, what a great question. And nowadays you also say, oh, why did I give that to GPT-4? No, I'm joking. I think that there are some easy things to do, and they come to mind as follows. First of all, these technologies are surprisingly random. So if you want different answers, just ask the same question over again. This is not like your grandma's computer program where you put in the number 5 and you get the number 17. Here you put in the number 5 and sometimes you get 17, sometimes you get 19. So there's just natural variation due to randomness in the program. That's number one. Number two, one of the ways that technology will advance, and this is something that the question very much gets right, is we will build prompts, we will refine prompts, and we will share prompts in the same way that today we build books, we share books, we have software libraries that we share, and we build on them. So the fact that we're going to have this corpus, this body of prompts that we're going to use and reuse, it's a good thing. Now, does it result in lack of originality? Not at all. Does the fact that we've all read, I don't know, Harry Potter result in lack of originality on our part? No, because we take Harry Potter, but then we have our own twist, right? I like whatever his name is, Dudley Moore, right? Kind of the fat kid who's mean to Harry Potter. I really like him. Don't ask me why, it's a long story. The point is that we can all have our individual approaches. We can take the standard prompt and put our little twist on it. So I'm not any more worried about originality than I am worried about the fact that pencils are going to be the death of thought. Many professors have emphasized the importance of motivation in learning. I'm curious to know what motivates you in your own learning journey. Thank you for that question. One of the challenges which was touched on in this summit, but I don't know that it was successfully answered, was as we build these educational technologies, how do we capture the inherent motivation? So I'm still waiting to learn on that. As for me personally, I would say that I got into this field literally about 40 years ago, being motivated by the question, what is the nature of intelligence? And I realized that it is not just a fascinating technical, scientific, and intellectual question, even philosophical question, but it is one of the most fundamental questions of all of scientific inquiry. It's kind of like the question, what's the origin of the universe? It's this meta question of which there are only very few. We are actually almost as far today from answering that question as we were in the Stone Ages, meaning a year ago, before ChatGPT was launched. So what we've seen is a tremendous technological advance, which I'm super excited about. But the advance of our theory of intelligence is much, much slower, and we should not confuse the technological advances with the fundamental advances. And so what keeps me going, even when I'm jet-lagged in Seoul, is the curiosity about the nature of intelligence, of true intelligence. Clear changes are expected. However, it is not well predicted what steps will be taken to bring about these changes. What topic will be discussed at this forum next year? If we were to predict the AI-related agenda for 2024, what would it be? I think the title of the forum could be, how could we have been so naive? Why did we do it that way when there's a much better way to do it? How is it that, no. It's a fantastic question, and let me give a more succinct answer. I really don't know. Your guess is as good as mine, but I do assure you that we will make, and we are making, a lot of mistakes. To me, so long as we're careful in making those mistakes to learn from them and to improve, that's not a bad thing at all. I would like to ask you about your thoughts in the significance of this year's, gosh, I don't want to mispronounce, Taejae Future Education Forum in relation to the development of generative AI. Additionally, I'm curious if you have any suggestions or directions for future progress in this field. I think this forum is really important because you're asking the question of how do we make the use of technology better for students, better for teachers, better for education. And so I think the significance is that the technology is moving very fast and there's a lot of investment in it. We need corresponding investment in important applications of it. And I can't think of a more important application than education. And my suggestion for future progress in this field is to be very empirical about what you're seeing. So I have heard a lot of claims, a lot of speculations, a lot of really exciting ideas in this forum, but we need to do more work to validate those, to run experiments, and there have been some. So if there's anything that I would like to say is I would encourage everyone to get very empirical, to do experiments using the technology, and next year when we come back, let's not just speculate about these incredibly cool things. Let's not just show examples. You know, Eric Horowitz and many others showed these wonderful examples, but we need more systematic data where we can make better analyses. And so I think we actually have a long way to go in the science of the use of AI in education, as opposed to the speculation about it. I hope that makes sense.
Okay. It's time to wrap up the Q&A session. Thank you so much for your presentation. 여러분, 큰 박수 부탁드립니다. 고맙습니다.